Per NEC Table 1, a 1.25-inch conduit has a maximum allowable fill of 40%. For 6 phases and 6 neutrals, the total number of conductors is 12. Assuming each conductor is number 12 AWGTHHN, which has a diameter of approximately 0.115 inches, the total cross-sectional area of the conductors is 12 times 0.115 inches squared, which equals 1.605 inches squared. The cross-sectional area of the conduit is 1.25 inches squared times pi divided by 4, which equals 1.23 square inches. Therefore, the conduit fill is 1.605 inches squared divided by 1.23 square inches, which equals 1.31. This exceeds the maximum allowable fill of 40%, indicating that the conduit is not acceptable. Per NEC Table 310.16, the ampacity of number 12 AWGTHHN wire in a 90°C environment is 25 amps. However, the rectifiers are rated at 14.5 amps continuous. Therefore, the wire ampacity must be derated based on the number of conductors in the conduit. Since there are 12 conductors in the conduit, the derating factor per NEC Table 310.15b2 is 0.8. Therefore, the derated ampacity of number 12 AWGTHHN wire is 25 amps times 0.8, which equals 20 amps. This is less than the continuous rating of the rectifiers, which is 14.5 amps. Therefore, the wire is not acceptable. Both the conduit fill and the conductor ampacity calculations indicate that the planned installation is not acceptable per NEC. Here are some recommendations. Firstly, use a larger conduit to reduce the conduit fill. Secondly, use a larger wire size to increase the conductor ampacity. Thirdly, consider using a derating factor of less than 0.8 if applicable.